vi ska titta på lite film här nu igen och då håller vi tummarna för att vi får se hela filmen den här gången. Och filmen den är från projektet Circulins som handlar om larver som äter plast. Efter filmen så kommer jag bjuda in Nathalie här som leder projektet och kommer från Norbite att prata lite med oss och även visa några ytterligare kompletterande bilder här till filmen.
Where we're working with a specific insect, wax moths. Those insects are able to digest plastic and polymeric materials, which we are producing every day in our everyday life. The plastic we are focusing on is unrecyclable plastic. It means that we are focusing on lasting waste streams where we have mixtures, when we have copolymers, smooth packaging, all those materials that cannot be recycled by other means. So we are clearly here to replace the incineration, and it's worth to know that during the incineration, for each and every kilogram of burned plastic and polymeric materials, 2.5 kilograms of CO2 are liberated in our atmosphere. And our process is reducing CO2 emissions by 67%. So basically the discovery was made by chance. People who were working with those specific insects for completely different purposes. They had them in a plastic bag and they got lazy, but left them overnight in this bag. And when they came the other morning, they have seen holes in the bag and insects everywhere. And they discovered that the insects were able to digest those plastic materials. So our goal is to go towards commercial units, which will be transforming 60,000 tons of plastic waste per year, which will be generating 20,000 tons of larvae. At the end of the process, we are separating it into proteins and lipids that can be used for feed industries, and the pulpy parts of the insect is used as biofertilizer. We have two different types of customers. First hand, we have customers that are interested by our service of handling of plastic waste, because as we are targeting the ultimate plastic waste with lasting waste streams, so that people are used to send to the incineration, and it's a costly procedure. So by offering a little bit lower prices than the incineration, we are actually capturing the interest of those customers. On the other hand, with the products that we are getting, the proteins and lipids, so we also have customers of our final products. So it's kind of a decided business model. When we are talking about circularity on Earth, it's kind of a nice have. But when we are talking about a long-distance space trip, the circular industry is no longer a nice have, it's a must have. So it becomes very mandatory to have this type of circular system when you are kind of reintroducing a waste from one branch to be a resource material for another one. So for feeding the astronauts and handling their waste, it's really interesting to have this insect process.
So now we will switch to English, and thank you very much, Nathalie Beresina, for your brilliant acting skills during this film, and welcome. So please introduce yourself and share your pictures.
Yeah, thank you very much, class. It was a very nice opportunity to present our work and what we are doing. So we can maybe just show a little bit more different pictures. Just let me share my screen. Yeah, great.
Now, perfect.
Now it's working. Great. Fantastic. So it's a Circulins project. So it's what we are doing to make this circular handling of plastic waste by the insects. So what we made just a few reminders about what actually this plastic waste is, because we all know that it's a huge problem, but sometimes we are assimilating plastic with packaging, but it's actually larger than that. It also concerns furniture, it also concerns textiles, and all this together, it's a huge amount of waste which is produced every year. And globally, the recyclability of this waste is very poor, and partially due to this presence of mixtures and copolymers that are very difficult to recycle by other means. And when they are burned, as it's said, it's actually very damaging for our atmosphere and for the CO2 emissions. At the same time, our current intensive agricultural systems fail to feed the world population in a sustainable manner. And both those problems are urgent and present at local and global levels. And as we have seen also, it's something that starts to trigger an interest from the space industry, because with current technologies, we are now able to plan actual trips to Mars and to the first extraterrestrial settlements. So our solution is both inspired by nature and scientifically proven. It is based on one specific insect, the wax moth, that in the wild lives within a beehive and feeds exclusively on the beeswax, which is a particularly interesting aspect, because it means that during millions of years of natural evolution, this insect has adapted itself to digest very difficult to digest substrates like wax moth, which is very similar actually to commonly used plastic materials that we are producing. And it means that this insect possesses the unique combination of microorganisms within its gut, which are working together on the digestion of those materials. And it has been shown that actually, depending on what type of material we are submitting to the digestion of those insects, actually the balance between the microorganisms within the gut is changing. But also, they have elaborated a system of specific enzymes produced by the insect that are accelerating the process. And those enzymes are namely present in the saliva, for example, that are helping to the digestion of those materials. So what we have developed, so you can see here, some pictures of what we can tackle. Those are foams that are present in mattresses, in cushions, in sponges. There are multi-layer smooth packagings. There are different types of textile. All those materials that are usually not recycled and only sent to the incineration. So we have tested more than 90% actually of commonly used plastic and polymeric materials in terms of their chemical composition, and all those materials were actually transformed by the insects. And at the end of the process, we obtain ingredients such as proteins and lipids that we are targeting for the feed industry. And basically, it's actually the focus of the Circulins project is to understand the relationship between the input and the output, and to qualify those final products to see whether they meet the requirements of feed industry. So that's why the work within the projects have been break down into 3 work packages, starting with the transformation of larvae of Galleria melonilla, the wax moth, the analysis of different ingredients, proteins, lipids, to check in their nutritional value, also to look into the innocuity in terms of presence of different other substances, because when we are talking about final products that are made out of polymeric materials or plastics, we are not talking only about polymeric chains. We're also talking about different additives like plasticizers, like flame retardant agent, and so on. So we need to check actually the presence and actually the absence of those materials within the end product, so that it can be used for fit purposes. And it's really the focus of the Circulins project. It's to look into the final product in terms of its innocuity. So there are also, of course, IPR studies and FTO assessment and broader communication around the project, because as I mentioned, the goal is when going to the production, to build a production unit, and for that we need partners within plastic industry, waste treating industry, so that we can work with them together and to build common factories that will be transforming those waste streams, because it doesn't make any sense to transport waste for kilometers. So the idea is really to have those lasting partnerships with waste treating industries and other owners of this plastic waste problem, so that the aiming into, I would say, double type of development, the actual industrial expansion with building of factories with walls and so on, but also the development of a licensing model, specifically for us to be able to go to the geographies where it would be difficult for us to go in person. So the team behind the project. So I have been trained and educated as chemist and chemical engineer with a PhD in biotechnology, and more than 15 years of relevant international experience, of which 10 years within bioplastic industry and 5 years within insect industry. So now I kind of combining those two competences. There's also Maxim Shapovalov, with his mathematical background. He's mainly focusing on the transfer of biological systems from laboratory to industrial scale. So we're also benefiting from the help of an international advisory board, mentors and experts of different incubation acceleration programs we are part of. And we are also working with some specialists specifically for the IPR studies with our patent. So yeah, Circulins, it's a project that aims in circular handling of plastic waste by the insects. And I will be very happy to answer any of your questions. Thank you very much for your attention.